Let's now learn about the final third design for the student management system problem. Especially, let's recall the criteria that we have set out in the second version, the second design. Remember, we said the ideal design should be we should have a single students array, whereas we should also satisfy the good design principles about cohesion and also single choice principle, right? Let's now keep that in mind and then see how the ultimate third design is going to satisfy all these three criteria. Specifically for the single student array, that has to do with the so-called polymorphic collection, which I will delay the discussion until the very end of the inheritance lecture. So let's now just focus on these two, about cohesion and also single choice principle. Let's now do that. Let me now go back to the slides and let me just move. I will go back to the Eclipse a little bit later, but let's now just talk about the slides and also the iPad. Okay, so that's going to be the architecture, how we organize the courses. So we got one class called resident students, and we got another class called non-resident students. So the idea about having two so-called subclasses between on two ends is actually for cohesion. We want to put all the resident student specific attributes into the resident student class, and the non-resident student specific attributes into the non-resident students class. And we have a so-called superclass. Here, the common, we're going to put all the common attributes like a courses and also name and also the way we register for the students and also the way we calculate the base amount for the tuition without applying any premiums or discount rate. We want to store all the common parts to really avoid duplicates. Store all the common part over here in the parent class called students. And the way we relate all the three classes is by saying resident students extends the students, and also non-resident students extends the students. Basically, whenever you say a class extends from another class, all the non-private, any attributes or methods that are not private from the parent class will be inherited automatically into the subclass. Remember, we talked about the visibility just earlier, right? So anything, as long as it's not private, it will be inherited into its subclass. But for simplicity, we assume everything we talk about here is simply package level visibility, simply no modifier. Okay, so that's about the extent. You will see exactly how to use it. And for the next few slides, I'm going to go over the three classes together with you about the students and also the two subclasses. Let me now switch directly to the iPad. You can definitely read about the classes definition yourself in more detail. But let me just go over them as well together with you. So that's the architecture I just talked about. We got the student class, the parent class. We got two subclasses over here, the resident students and also non-resident students. Okay, let's talk about the common part over here. You can see here the name and also the courses over here. This part over here will be inherited verbatim to the two subclasses. And also this definition over here, actually all the methods in the parent class, they can also be reused if you call them. Okay, so this part over here may be reused, and I'll show you exactly how to reuse it. We're going to use a new keyword called super. Okay, and also this method over here can also be reused as well. Right, and also this part over here about calculating the base amount, this can also be reused. Okay, can notice that in the student class over here, we only talk about how to calculate the tuition, the base amount, just by going over all the courses and sum up their fees. That's all we do. We didn't apply any premium rates or discount rate. That will be up to the individual subclasses. That's something we'll see. Okay, so all the methods over here can also be reused, and also the constructor. Okay, and on the other hand, the attributes over here will be inherited to each subclass. All right, having that in mind, let's now look at each of the subclasses and see how we can use them. Okay, let's take a look. Let's now look at maybe the first subclass, resident students. So for the resident students, you can see it says that it extends the student class, extends. As soon as you do that, you actually say the student class over here is a superclass or parent class. And similarly, you can see for non-resident students class over here, we also got the same keyword over here, right? You say extends the students. So in terms of the terminology, we would say both of these classes are the subclasses of students. And how do we call the relationship between them? If you really want to say they are like the sibling, okay, there's another way to call them. So you can think about these two classes because they have the common parent class, so they're called sibling classes. All right, hopefully it makes sense to you because a sibling simply means brother or sister, right? Just sibling classes. And then let's now go a little bit further. So this part over here, we say double premium rates and versus, you can see here, double discount rates. So this will actually make sure we satisfy which design principle? The cohesion design principle. Let me just illustrate that, right? So let's now try to highlight it. Actually, purple should be okay. So if you look at this part over here, premium rates and also discount rate, we make sure these two attributes are not really mixed in a single place, in a single class, like in the first design. So this will satisfy cohesions. Okay, let's now go a little bit further. And you will also see in the constructor over here, resident and students. You will simply take a string name and notice that we actually got super and then name. So this is important keyword for you to learn, like a super. Okay, so super and name over here, and you will see something similar here as well. Also super and then name. And both super keyword over here is really referring to the parent version of the constructor. Okay, so this one over here is really referring to this part over here. Okay, the parent version of the constructor. And similarly, you can see the super over here, we are also referring to the parent version over here. Okay, so this will be as if you actually invoke students constructor and then you pass just the argument name over here. All right, so hopefully that makes sense to you. You can definitely feel free to actually start using the super keyword. So in the case of calling the constructor, remember actually when we talk about composition, let me draw some connection there. When we talk about composition, when we want to call other instructor as a helper method, how do we do it? We actually say this, and then we put some arguments over here. It's kind of similar, but now we are trying to invoke the constructor from the parent class, immediately above parent class. And later on, we're going to see you might have parents, grandparents, and grand-grandparent classes. But whenever we use super, it's only for the immediately parents, the immediate parents. Immediate. It is not possible for you to say, I want to call the constructor of the parents of the students. I cannot do that. Okay, you can only say, I want to call the version of the constructor of my parents. In that case, it will be the students. Okay, so that's about constructor. And then we got something similar. Let's see get tuition. You can see get tuition over here. As I said before, we definitely got this part of the method, the body of the method actually available to you. So what you can do is you can say super.get tuition. What I want you to really contrast is what we actually used to write is simply say this dot get tuition. However, in this case, you definitely don't want to say this dot get tuition. You don't want to, right? Because if you only say this dot get tuition, you're saying that in order to define the get tuition method, I'm simply going to call itself. What you will do is you're going to end up into infinite recursion, in which case you will never terminate your code. That's not a way to do it. Okay, so if you write it, it's going to be infinite recursion. And we'll talk about recursion a little bit later in the course, but this will definitely get you into infinite recursion. So what we do instead is to call the super version the parent class. Okay, so this super keyword will always be some context objects. So think about the super keyword over here. So this is like a context objects referring to the parent class. Context objects referencing the parents class. In this case, the parent class will just be the students. Similarly, you can see in the sibling class over here, in the get tuition, over here, we simply say the base amount is simply assigned to super.getTuition. And here, rather than this, we simply say super, right? So you really want to compare these two usages. Let's now highlight it. You can see here we got super over here, and also we got super over here. And then once we got the base amount, you can see the two subclasses will handle the rest differently. For GetTuition under resident students, we'll simply say base that multiplied by premium rates. Versus in the case of non-resident students, once we get the base amount from the parent's version of GetTuition, which will invoke this block of code, we're going to apply discount rate on top. All right. Another question you might have. In this case, we simply say super.getTuition, where the getTuition is actually an accessor method. Okay, let me just emphasize that. So the getTuition over here is an accessor method. Accessor method. And when we say super.getTuition, we are simply invoking the version of this accessor in the parent class. That's what we're doing. What if we want to invoke a mutator method? What can we do? Okay, let me just hypothetically, let me do that for you. Okay, let me just emphasize that as well, just for completeness. Can we just say maybe also from here, just to continue the non-resident students class, if you really want, what you can do is, let's say you may want to redefine the register method. What you can do is you got to redeclare that. You got to say void and then register. And of course, the register also got one parameter for the course, right? So here you're going to say course and then C. Okay, so we are just redeclaring the mutator over here in the context of this particular subclass over here. Subclass. And in the body of the implementation, what can we write? Okay, so what you can write is, let's say in the body of the implementation, so let's say, how do we say we want to do whatever the parents did, first of all, to begin with, and then we want to do something else. What you can do is you can say super, which will refer to the parents class, and then super.register. And then you can put C inside. And then you can just continue the body of the method with other code if you wish. Okay, I'm just trying to show you how you can actually write the super keyword for mutator method. Right? The principle is the same. You just use a super keyword over here. And versus if you simply say super and then put a parenthesis, that's only for invoking the parent version of the constructor. Okay. All right, let me say one more thing. We just mentioned that having these two attributes being split into two different classes, that's for satisfying the cohesion design principle. So what about the single choice principle? Do we have any code duplicates? The answer is no, actually, because you can see everything that should be common to both the resident students and also non-resident students, namely name and courses and the counter, the body of the constructor, the body of the register method, and also the part of the base amount calculation for the GetTuition. All of them are actually defined in the parent class, and they will be inherited verbatim into the two subclasses for reusing. And whenever we want to reuse it, we can use a super keyword. In the case of the register, since we don't need to do any further overriding or redefinition, there's no extra code like in this case we have to write. In that case, we simply don't need to do redeclare that. We can simply call that. Okay, you will see later. Let me say just put one more point over here that's also very important. So for the green one, so about all the common part, this will satisfy single choice principle. Single choice principle, right? I'm just trying to describe the three classes more from the compare and contrast perspective. But of course, you can also look into the definition for the precise definition in the slides. I'll also show to you the Eclipse code that I made available to you as well. Okay, let's now move on to the slides. Okay, so these three slides about the three classes I already talked about, so you can definitely refer to them. Okay. Let's now move on. Okay, so that's the architecture and the terminology about parents or superclasses in the case of students, and also for resident student and non-resident student, that'll be child or subclasses. That's some terminology I mentioned in the equals method module earlier, so that should be familiar to you. Okay, so I would say resident students and non-resident student, there are two subclasses or two child classes of students. Symmetrically, I would say students is the common parent class of these two classes.